In the second lecture of Maxima software, that is soft skill lecture, we discussed the concept of partial derivatives or solving a partial differential equation. In previous lecture, we discussed the mixed derivative, that is the derivative with respect to x, derivative with respect to y, and so on. Now we solve the given problem. Now problem is that determine whether each of the following equation is a solution of Laplace equation. What is Laplace equation? It is partial differential equation which satisfy uxx plus uyy equals to 0. आता तुम्हाला u of x y चे 3 फंक्शन दिले, त्याच्यापैकी कोणते इक्वेशन लॅप्लास इक्वेशन आहेत. आता इक्वेशनच्या वेळेस ते डिफरन्शियल इक्वेशन सॅटिस्फाय करेल त्यावेळेस आपण काय म्हणू, ते लॅप्लास इक्वेशन आहे. मग आपण हे कशाने सॉल्व करायचं, मॅक्सिमाने. मग मॅक्सिमाने कसं सॉल्व करायचं, त्यासाठी पहिल्यांदा आपल्याला फंक्शन इंट्रोड्यूस करायचं आहे. व्हॉट इज अ फंक्शन? फर्स्ट वी हॅव टू इंट्रोड्यूस द फंक्शन यू ऑफ एक्स वाय. आपण नंबर 1 क्वेश्चन पहिल्यांदा सॉल्व करून घेऊया. यू ऑफ एक्स वाय काय आहे, एक्स स्क्वेअर प्लस वाय स्क्वेअर, अँड वी हॅव टू चेक दॅट यू एक्स एक्स प्लस यू वाय वाय इक्वल्स टू 0. therefore we here is a screen of Maxima. We solve for first function, that is we first step is that we have to represent a function u. आता u काय आहे, तुम्हाला दिलेलं फंक्शन आहे. मग आपण रिप्रेझेंट करूया. u रिप्रेझेंटेड ॲज एक्स स्क्वेअर प्लस वाय स्क्वेअर. हा काय झाला तुमचा u झाला. आपण एंटर म्हणूया. ओके, हा झाला u. मग u तुम्ही एंटर केला. u फंक्शन तुम्हाला इथे डिस्प्ले होतं आहे, एक्स स्क्वेअर प्लस वाय स्क्वेअर प्लस एक्स स्क्वेअर. आता नेक्स्ट काय फाइंड आउट करायचं, u ची डेरिव्हेटिव्ह विथ रिस्पेक्ट टू x, then again differentiate with respect to x, same for y. Therefore we first upon find out ux, uy, then uxx, uyy, and then we have to check that its addition is 0 or not. If it is 0 then it satisfies, non-zero then it does not satisfy. Now next claim is to find out ux. Ux means derivative of u with respect to x. And what are the commands? Commands for ux are nothing but say denoted by ux as, what are the command? In previous lecture we see the command for differentiation. What is the command? Diff, that is diff. It is command for differentiation for a function u with respect to x. With respect to x, therefore comma x, round bracket complete. What is the answer? Answer is 2x. Okay, answer is 2x. Now similarly calculate uy. Therefore now the changing the notation uy, it is differentiation of u with respect to y. Then enter. What is the answer for uy? It is 2y. Then we have to find out uxx and uyy. Therefore again differentiate ux once time, that is actually differentiate u with respect to x 2 times. Notation is uxx. It is differentiation of u with respect to x with 2 times. Therefore we simply here write down 2 and enter. We get the answer. That is answer is, what is answer of uxx? Answer is 2. Similarly calculate uyy, and the command is uyy, that is differentiate u with respect to y 2 times. Therefore command is uyy denoted by diff u comma y comma 2, and answer is, what is the answer of uyy? It is 2. Then we have to check that its addition is 0 or not. Then we adding that to function, that is addition of uxx, plus uyy. We have to check that addition, that is uxx plus uyy. What is answer? uxx plus uyy. Answer is, चला आन्सर काय आलं तुमचं 4. But we have to check that the Laplace equation satisfy uxx plus uyy equals to 0. Therefore number 1 function does not satisfy the given equation. Similarly we have to check that is that number 2 function satisfy the given equation. What is number 2 function? For that again representation of a function, we kill the previous commands. By which command? That kill context command. Kill context command. Therefore we remove the previous all that commands. Again we have to differentiate u for the function x square minus y square, and same for sin x into cos hy plus cos x into sin hy. The second problem is similar for the first problem. You can do this. Now the third we represent a new hyperbolic function and so on. Therefore we check for number 3, that is u of xy is equals to sin x into cos hy plus cos x into sin hy. Therefore first upon we represent u as, what is the function u? U is represented as sin x. Sin variable is x, therefore write down into bracket x, sin x into cos of hyperbolic, that is cos h of variable y plus cos x into sin hyperbolic, that is sin h of variable y. This is our function and we have to check for that function whether it is a Laplace or not. On the same way, we first find out the ux. What is ux? By the usual way, ux is a differentiation of u with respect to x. Therefore in simple command it is calculated as dif u comma x. Then enter, we get the solution. What is solution? Ux is find like this. Similarly find out uy. What is uy? Derivative of u with respect to y. We obtain uy. Again find out uxx and uyy. What is uxx? The derivative of u with respect to x 2 times. Therefore uxx is equal to diff u with respect to x comma 2. Enter. Answer is given. Same find out uyy, that is uyy is treated as diff u, that is differentiation of u with respect to y 2 times, and it is answer. And finally check that whether uxx, it is a uxx plus uyy is equals to 0 or not. If it is 0, then it satisfies the Laplace equation. If it is non-zero, then it not satisfy the Laplace equation. Uxx plus uyy. What is the answer? Uxx plus uyy. Sorry, we have to calculate uxx plus uyy. What is the answer? Answer is 0. Therefore uxx plus uyy equals to 0, and the function u of xy equals to sin x into cos hy plus cos x into sin hy. It is an Laplace equation. Now the next command is for multiple integration. The integration, double integration, triple integration, for the evaluation of integration we have to solve the Jacobian of that function. This is that double integration we see in advanced calculus. These are the commands for Jacobian of round bracket f comma x. The integrating commands are integration, write down round bracket expression comma with respect to x, and integrate expression comma x comma a comma b. This gives an limit of that integrations. Now these are the simple commands for the integration. Now we have to evaluate double integral. That is, for evaluate double integral x cube minus 3xy dy by dx, we see the demo in the Maxima. We first kill all the context. For the evaluate that double integral, first claim is to represent the function f of x comma y, that is function in two variable, are the what are the given function of xy equals to x cube, that is x raised to 3 what are the function. We have to solve the function f of xy is equals to x cube minus 3xy, that is minus 3 into x into y. It is function. First we represented that f of xy, that is x cube minus 3xy. To evaluate double integrate, for the single integration the command is integrate. For the double integration we have to write down 2 times for integrate command. Here we have to evaluate double integral, therefore write down integrate command 2 times. Integrate, write down round bracket, again use the integrate command, integrate, write down round bracket. What is function? Function is f of x comma y, here is f of x comma y, comma, what is variable, that is dy by dx, therefore y round bracket and dy dx, then x round bracket complete and then enter. It gives the answer x raised to 4y minus 3x square y upon 4. Same we have to evaluate for the limit, that is second problem. Integral runs from 0 to 1 and square root of x to 2 minus x. This can be done by the same command, integrate, open bracket integrate, comma f of xy comma y, f of xy comma y, comma x runs from, that is we write down x runs from that expression, that is a comma b, x runs from 0 to 1 and y runs from x raised to half to 2 minus x. Now first command is f of xy comma y, that y runs from square root of x, that is it may be write down as x raised to half x raised to half, round bracket complete, x raised to half to, what is upper bound, 2 minus x, round bracket complete, and what is the range for x? Now x runs from 0 to 1. Evaluate. What is solution? Solution is minus 287 upon 360. It is and final answer. On the same way we can evaluate in terms of polar coordinates that given in the solution, but using polar coordinates, here we have to evaluate using polar coordinates, but using polar coordinates we have to represent nu, that is pi, but for the symbol of exponential function pi we have to represent all that symbol by percentile. Therefore using polar coordinate we can easily find out double integral of x square plus y square dx by dy. What are the polar coordinate? X equals to r cos theta, y is equals to r sin theta. Here are the given things, and we have to evaluate the double integral over the polar coordinate. Let us see the demo in Maxima. First we kill all the context. It is done. In the polar coordinates, we first introduce the function f of xy. What is the given function? F of xy is equals to काय दिलेलं आपल्याला function? x square plus y square. X square plus y square. Then done. Now we have to represent polar coordinates. What are the polar coordinates? We know that the polar coordinate x equals to r cos theta, y is equals to r sin theta. Therefore we represent in terms of order pairs x and y. X and y represented as x equals to, for the polar coordinates we use square bracket. Here we mention the sign of equality. X equals to, what is value of x? R into cos theta. What is we represent theta? THE round bracket complete. And what are the values of second variable? That is y. Y is equals to r into sin theta. That is sin of theta. R sin theta, round bracket complete, square bracket complete. That is, it is a representation of x comma y. So, therefore we get the values of x and y. That is if x y represent, and we represent x and y as r cos theta and y represented as r sin theta. What are the error? Here equality is not allowed since we represented an order pairs, therefore equality delete. Now for the double integration, our command is integrate. For the double integration, 2 times integrate integrate round bracket, again integrate. What are the integration of a function? F of x comma y, round bracket complete, star r comma 0 to 2, that is 0 comma 2 into cos of theta, that is cos of theta. Double round brackets are complete, and theta runs from pi minus pi. So before representing pi, use the percentile symbol, percentile pi divided by 2, comma, again use the same symbol, percentile pi divided by 2, and complete the round bracket. What are the error? Errors are integrating function f of xy on the variable sorry, here is multiplication. Multiplication of r, integrate round bracket, integrate round bracket f of xy multiply by r, comma r comma 0 to, there is a command is repeated, answer is 3 pi upon 2. Now the range of r from 0 to 2 cos theta. Therefore on the simple way we can find out the multiple integral using maxima. Hence we evaluate the result. Same we can done for triple integral and so on. So we will stop here.